Hello everybody, welcome to my YouTube channel Easy Mathematics, and our today's topic is power series. So first of all, what is power series? Before that, I hope all of you are comfortable with the geometric series. It is the continuation of that one. So now the power series is what? A series of the form summation of n from 0 to infinity an x minus x0 to the power n is equals to a0 plus a1 x minus x0 plus a2 x minus x0 its whole square. In this way, if it continues, then it becomes the power series. Here just remember, an is the coefficient and any variable which is in the power of some n. So this one is a power series which we can write in this format also. Here if we just replace x minus x0 by x, then only we will get this form, where the coefficients a0, a1, a2, all these up to an and up to infinity are independent of x and is called a power series in x. For this power series, here what to do? Our target is same. We are supposed to verify the nature of this series. Nature of this series means it is divergent, convergent or oscillatory for which values of x that we are going to find out here. So first of all, we should analyze what situations may arise. So first of all, when in this series we will find out x is equals to 0, then what happens? We just consider this one. If x is equals to 0, then what we will find out? All those terms becomes 0 except this a0. That means when our value of x becomes 0, then the series is definitely convergent. So whatever be the given series, if it is a power series, then at the point x is equals to 0, it is definitely convergent. Now if x is equals to 0 and no other values of x for the series is convergent, then the series is called the nowhere convergent. Except x is equals to 0, if for no other values the series is convergent, then we say the series is nowhere convergent. Now if we will find out for whatever be the value of x, we will find out the series is convergent, then we say the series is everywhere convergent. So what we will find out? Three things. If x is equals to 0, then it is sure short convergent. So x is equals to 0 is the special case for the power series. Always it is convergent for x is equals to 0. Except x is equals to 0, if for any other values the series does not converge, then we say the series nowhere convergent. And if it is converges all values of x for, then we say it is everywhere convergent. Now it is possible that the series converges within a certain interval of x. That particular interval of x is called the interval of convergence, and that particular value, that means the end point of this interval, is called the radius of convergence. Definitely we are going to discuss in details what is the interval of convergence and radius of convergence. So these facts, we will find out 4 facts: when x is equals to 0, when x no other values for the series convergent, when x all values for the series is convergent, and when for some certain values for x the series is convergent. These 4 situations we will find out. All those situations we will analyze with an example. So here is the first example. What is given? Here the power series is given summation n factorial x to the power n. That means if we expand this one, we will find out the series as 1 plus x plus 2 factorial x square plus 3 factorial x cube in this way. So that here un is definitely n factorial x to the power of n, and we will find out that n plus 1 is n plus 1 factorial x to the power n plus 1. Now what to do? We just take the ratio of these two. If this, we will consider the ratio of these two within the mod and take n tends to infinity, then we will find out the value comes as n plus 1 mod x, which definitely tends to infinity as n tends to infinity, because here n plus 1 is given. Now the series is divergent except when x is equals to 0. That should be our conclusion, because we will find out the value, the limiting value tends to infinity. That means except at x is equals to 0, we will find out the series is nowhere convergent. So this is our first situation. Now it is, if the series is given like summation of x to the power n divided by n factorial. So that in expanded form we will find out as 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial in this way. Here un is x to the power n by n factorial, and accordingly un plus 1 we can find out. Now if we take the ratio and take the limit as n tends to infinity, then we will find out the value is 0, which is less than 1. Hence, we can conclude from here that the series converges for every value of x. Hence, the series is everywhere convergent. In the previous case, we will find out the series is nowhere convergent, as we will find out except at the point x is equals to 0, the series is divergent. Now, in the second case, we will find out the series is everywhere convergent. Let us do one more example, and this one is a very important, because from this one we can understand the interval of convergence and the radius of convergence, and the given series is summation of x to the power n only. So if we expand this one, we will find out this is 1 plus x square plus x cube, and this one. And I hope you can guess that this one is nothing but a GP series. Yes, it is a GP series, and we know how the GP series convergent, when the GP series convergent, when it is divergent, when it is oscillatory. So according to that knowledge, we can say this geometric series is convergent for mod x less than 1. That means it is convergent in between -1 to +1. It is the open bracket. So, which is the interval of convergence? This range of x is called the interval of convergence, and the value 1, the mod x is less than 1. So, this is the end point of this interval. So, this one value is called the radius of convergence. Do you understand? The interval of convergence means for what value of x the given series is convergent, and what is the maximum value or the end value in the interval. That value is called the radius of convergent, which is denoted by either capital R or small r. Now, the definition for the interval of convergence and the radius of convergence. So, it says that the interval of convergence, which we can write as -r, r, or it is -r to +r. So, of a power series in x is a collection of all values of x in the interval such that the series converges for every value of x within the interval and diverges outside the interval. That is, the power series, if it is given summation an x to the power n, not only converges but absolutely convergent for all values of x inside the interval of convergence. This is our interval of convergence. Inside this one, it is not only convergent but it is absolutely convergent, because we will find out that the mod r less than r, and definitely then it is diverges for mod r greater than r. Then r is called the radius of convergence of the power series. Now, if we find out this radius of convergence, then for that we have two basic rules in the power series. Both the rules are known to us. First rule, by using the D'Alembert's ratio test, and second rule is using the Cauchy's root test. I hope both the names are known to you. So let us discuss the first rule, how to find out the radius of convergence for power series. For that, the rule 1. At first, this one is your given power series. For this power series, radius of convergence can be determined by the ratio test. Here, r, which is the radius of convergence, is equals to limit n tends to infinity mod of an divided by an plus 1. Just observe, this is just the reverse of D'Alembert's ratio test. In D'Alembert's ratio test, we will do un plus 1 by un. Here we will take un by un plus 1. Here I have taken an, that is just the coefficient of this one, because we know that this ratio means it is always giving us the mod x. So that r value is just the reverse of ratio. So that r we will find out by this rule. So if this one is fail, then what we will do? That means when it is fail at first, you know that if we will not find out any unique value for this one, this ratio basically, then we can say this rule fails. That time we go for the Cauchy's root test, which is the rule 2 to find out the radius of convergence for the power series. Now by using this second rule, here again we know the root test for the formula is limit n tends to infinity mod of un to the power 1 upon n. Here we take the reverse of this one. That means whenever you are finding out the radius of convergence, then it is 1 upon this rule, then it is the radius r. Here one thing should be noted, that if this limiting value, this is the formula for the Cauchy's root test, if this limiting value is 0, then definitely the radius of convergence is infinity, because it is reverse of this one, 1 by 0, so that is infinity. And when this limiting value is infinity, then the radius of convergence is 0. So that is for r is equals to infinity, which will implies that the given series is everywhere convergent, and for r is equals to 0, it is implying that it is nowhere convergent except at x is equals to 0. Now we should validate both this rule by using some examples. So here is our first example. The given power series is x plus x square by 2 square plus 2 factorial divided by 3 cube x cube plus 3 factorial by 4 to the power 4 x to the power 4, plus in this way the series is. So obviously this one is a power series, because whenever the terms are involving like x, x square, x cube, x to the power 4, then it is under the power series. So first of all we should find out what is the an here. So here the an is n minus 1 its factorial divided by n to the power of n, and an plus 1 is definitely n factorial by n plus 1 to the power n plus 1. Now if we take the ratio test, so that according to the ratio test we will find out the limiting value is 1 upon e. So the radius of convergence is what? It is just the reverse of this one. That means the radius of convergence r is equals to e. And what is the interval of convergence then? The interval of convergence is definitely then minus e to plus e. So this one is the interval of convergence, and r is equals to e is the radius of convergence. Let us do the another example. So in this example we will find out that the given series is x minus x square by 2 square plus x cube by 3 square minus x to the power 4 by 4 square in this way. So this one is an alternating series. So first of all an is minus 1 to the power n minus 1 by n square. So accordingly an plus 1 is minus 1 to the power n by n plus 1 its whole square. If we apply the ratio test, then we will find out the value is 1. Therefore, the power series has the radius of convergence r is equals to 1, because 1 its reciprocal is 1 itself, and the series converges within the interval minus 1 to plus 1. Just remember here the mod x, actually it is mod x value. If it is less than 1, then this value we will find out, and if it is greater than 1, then the given series is divergent. So accordingly when x is equals to 1, then what happened? So when x is equals to 1, then our series becomes this one, which is the completely an alternating series, which is alternating as, so we apply the Leibniz theorem. So according to the Leibniz theorem, we will find out this one is a decreasing series, and its nth term when n tends to infinity becomes 0. So by Leibniz theorem we can say when x is equals to 1, the given series convergent. So definitely we should test when x is equals to minus 1, because these two are the end points of the given interval. So now when it is minus 1, that time the series becomes this one. So accordingly if we just simplify, then we will find out that this one is nothing but a p series, and the p value is 2, which is greater than 1. Hence the series is convergent at x is equals to minus 1, 2. Therefore the interval of convergence of the power series becomes minus 1 to plus 1, which is the closed bracket. That means minus 1 and plus 1 both included. Now one more thing, or one more example let us see. So find out or convert the series into a power series and find the interval of convergence and the radius of convergence. This problem I am not going to do for you, and I can give you a hint that how to solve this one. You just put this 2x plus 1 instead of this one as y, so that it becomes minus 2 to the power n y to the power n by n square. Now I think it becomes easier. Now you just do find out the interval for the variable y. After that, finally, after getting the interval, you replace this y by 2x plus 1 and accordingly you calculate the interval. So that question you should complete by yourself. Not only this one, except this one, 4 more questions are there for you, which is your practice questions. After doing all those questions, you should write their answer in the comment box. So I am just showing you the 4 more questions which are your do by yourself questions, including this one also. So now look at the question. So your first question is actually for all you should find out the radius of convergence for the following series, and for the first question it is summation n to the power n by factorial n into x to the power n. Your second question is 1 by 2 into x plus 1 into 3 by 2 into 5 into x square plus 1 into 3 into 5 by 2 into 5 into 8 x cube in this way. Your third series is x plus x square by 20 plus x cube by 3 into 10 square plus in this way the nth term I am given here for you. It is x to the power n divided by n into 10 to the power n minus 1. And in this way it is up to infinity. And the finally one more series which is here 1 by 4 minus x plus x square by 4 square minus x cube plus x to the power 4 by 4 to the power 4 minus x to the power 5 plus x to the power 6 by 4 to the power 6 minus in this way this series progressing. So complete the answer for these all 4 questions. And I hope you understand the power series, which is almost known to you because geometric series is very much similar to this one. Not only this geometric series, but the E series or log series, sine series, cos series, all are the power series. So how to do all those series, that we will describe gradually on our upcoming videos. The next video we will do some little bit advance on the power series, infinite power series. So this video is beneficial for the any competitive examination like GATE, NET, anything. So I hope you like the video. So have a nice day and thank you all.